This is a video talking about coding and using Scratch. First off, in the Victorian Curriculum, it says in the mathematics section, if you actually download out of the Victorian Curriculum homepage, there may be content descriptions and elaborations, and I'm just going to look at years 7 and 8. If I download a PDF of those, I actually end up with this. If I do a quick search and I look for algorithms in the Australian Victorian Curriculum, it says design and implement mathematical algorithms using a simple general purpose programming language. So it talks about algorithms, but it particularly talks about a programming language. So I'm going to look at using Scratch to do this. Further on in the Year 8 curriculum, it talks about using algorithms and related testing procedures to identify and correct errors. So we could use that for debugging some of our Scratch programs. Okay, so let's have a look at Scratch. So in my search engine, I'm going to type in Scratch and see what I get. I'm looking for this one here, scratch.mit.edu.au. So when I get it, the portal looks a little bit like this. You can actually sign in and create your account, but your students could actually just work live from this section. So try it out is what we might do. Here I can see here is a sprite. This section over here I can create little programs, and in these sections here will give me the tools that I actually need to do that with. Now I'm actually going to go back and actually search some files that have been created by myself. This is one word, Steve Francis. So if I do the search under Steve Francis, there is some files here that you could find. I'm just going to quickly run through some of these files. First off, our students in Year 7, we start off with some coordinate geometry work. Here we're loading up a project. I'm going to enlarge this one here. To start Scratch, to actually run a little program that's been written, you press the flag, and this one there are some penguins. Now there's a wizard hiding down off the screen. Maybe I could get hold of the wizard. There's a wizard off the screen. Now he's suggesting that I could actually go to these locations. -87, -9. -87, -9. If I click on that sprite, he plays a song. It's suggesting play it twice. 165, -40. 165. Oh no, positive 165, -40. 183 and 33. So 183 is a positive and -40. So the first one but nevertheless, pressing the right ones will play Twinkle Twinkle Little Star. So playing in an order, here we go. Lovely Twinkle Twinkle Little Star. And if we press it again, our penguins have moved to another location, and then our students can actually identify those coordinates. So the purpose here is to get our students familiar with how to run the program, how to operate and work within the section. If you wanted to look inside, you might be able to find there's some coding in there for each of the penguins, some coding for the conductor, that operates that. But nevertheless, students don't need to go there straight away. If I go back, I might be able to look at some of the other things that we've got in here. This one here, students could do some coding to work out some angles. This is a reasonably simple one. I might actually look inside so we can see what's going on. The first one asks our little sprite to draw a triangle. And you might be able to work out how we did this. Drew a line, came back, created an angle. Drew a line, came back, created the angle, and repeated it. So a lower level student might find that a good thing to do. To work ahead, the student could just change the code. This one's got repeat 3, this one's got repeat 4. And of course, as you go along, you could get students to work at a higher level and change the codes to achieve different ones. Again, this could be incorporated into some students' angle work. Let's have a look at another one. So, going back, yes, I'm happy to leave the page. Going back, this one here is on tessellations. Now again, the students might be able to create the codes. I've put some codes in here. The first one is a triangle. Great fun. Students could maybe achieve the code there, but what's actually happening? Our little sprite has drawn a line, turn left, drawn a line, turn left, drawn a line, and that's created a triangle. Then our sprite has moved, repeated that 6 times. Once the sprite has drawn those triangles, it's actually moved from here up to here, changed colour, and repeated 5 times. So as a beginning task, a student might be able to achieve that. Working at a higher level, students might be able to change it around using exactly the same code, but changing what they're doing. This time, on this code over here, you can see that they've moved 30 and turned 45 degrees each time to create a hexagon. They've then moved for the next hexagon and drawn it. They might have to take out some time to work out how far to move, but again, they could repeat that 5 times, move back up to here, draw a hexagon, so maybe students could do that. Our top students might be able to introduce a variable and ask our Scratch to ask a question, how many sides would you like, and ask it to tessellate it. So again, there's something a little bit to do with geometry. Let's have a look at maybe something that could be linked to algebra. This one here called matches and boxes. If I look into matches and boxes, and if I go inside, I'm going to move across to the right hand side by scrolling the bar across. I've got my sprite drawing a box, and each time my sprite does it, my sprite is using 3x on matches. This is an activity we always do over Year 7. Start with a match, add 3 matches for each box, so the kids can develop the pattern, starting with 1, increasing by 3. They would then move into making it into a table. They would then move into making it into a graph, and this could become their activity or their project to do. If you look at these, I've got it in different steps. So if you looked at a basic one, I've just got our sprite drawing 1 box. In the next part, I've got the sprite drawing a lot more boxes. And then as you move across, I've had some complexity. So this is how the student might learn. You can see I've got it increasing, but it's pausing each time. So that's something that you could actually have a look at to do with algebra. Let's go back and have a look at some of these other ones that we've got. Yes, I'm happy to go back. And yes, I'm going to go back again. You might, so tessellations, angles, algebra, starting maybe with some penguins. There's some things that you could look in tossing coins and other sorts of things, but there's some of the things that you could explore. The concept we're thinking about at Kew High School is to start by introducing the students to Scratch, and then once they've been introduced to Scratch, incorporate a little bit of Scratch in each of the activities. This activity here is a reflections activity. I might actually have a look inside. I've got one cat who will actually draw on this side of our reflecting line, and another one drawing on the other side of a reflecting line. I did that by creating cat 1, and then I duplicated cat 1, and once I had the duplicate, I went and changed the code for cat 2 to make sure he draws it. So when I actually did that, I've actually got two operating at the same time, and you can see I'm creating a reflection. You can see that the code for cat 1 and the code for cat 2 are very, very similar. One's obviously starting in a different place, and then this is a way that we can work with reflections in our coding. So just a reminder, this is a program's called Scratch by MIT. It's got a section where students can see the actual software working, a range of operators and controls that we can write our software. We'll actually look at in another video how to do that. But over in this section, getting started with Scratch is quite interesting. If you click on a little tutorial, you can see what you could actually do, and you could actually follow the instructions and see what actually happens. Ask it to, play a drum. Okay, a sound. Play a drum for 1 beat and click on it. So we could get our, to do that. Now we could get it to make a dance, move 10 steps, play a drum, and then move another 10 steps. So there's a nice tutorial on the side, and then maybe play the drum again. Okay, so, and you could change all those sorts of things, follow the instructions, and get the students to see if they can work their way through it. Thank you for watching this video. It's Steve Francis from Kew High School.